Okay, this is the 3.7 to 3.8 review. Calculators are still allowed, and this is number 8, corresponding to a multiple choice problem. There are multiple things that I ask on this problem, and they all stem from a chart of data for the position and the time for a particular moving body. So part A says we want to estimate the velocities, and velocities are derivatives. And if you recall, we compute derivatives out of charts of data by examining flanking points. So if I want the velocity at 2, I'm going to use these 2 points and I will set up a slope. So let me go here. My velocity at 2 will be approximated by the 18 minus the 12 over the 2.5 minus the 1.5. So I get a 6 feet per second. I'll do one more of those. Say, let's do 3 here. My velocity at 1 will be approximated by the flanking points. So I'll have a 12 minus a negative 6 over a 1.5 minus a 0.5, which is 18 feet per second. And the others work enough alike that you could probably figure it out without me having to go through all of them. So part B says, when does it appear that the body changes direction? Now remember, direction changes, that's information about how the particle is moving. So it's velocity that will tell you how you're moving. So what I would look for is a velocity that is 0, because that's typically when we have stopped, and then we will either turn around and head the other direction or we'll continue on. So if we look for a velocity that is 0, that means we need flanking points that have the same y coordinate. And we can see that right here, flanking the 2.5 and the 18. So when it appears that the body changes direction, it looks like it's happening at t equals 2.5. And the position at that time is 18 feet. Okay, the last part, D, where you sketch a smooth curve for both the position function and the velocity function. This is, can you chart your data? Can you choose an x-axis with the tick marks that are appropriate? Can you choose your y-axis with the tick marks that are appropriate? And can you plot them? And with part A, you're finding velocities. So again, you would find the time, plot the velocity, and then connect it. So I have that picture on my review already. I'm not going to go through how you would do that. I think you could all do that without me.